So today we're going to start on factoring. Some of you may have had a little bit of factoring in Math 70, so if you did, this will be a kind of a review for you, because with the next section, factoring is pretty important. So that's why, even though you may have had it before, we're going to go over it again just to make sure you remember the steps. Okay, so we're going to start off with the greatest common factor. Okay. Now, just to give you an idea of just the definition of a factor, let's say, for example, we know that 6 is equal to 3 times 2. Once you break a number down, or in some cases a polynomial down, to just something times something times something, all of those multiples are called factors. So in this case, 3 and 2 are factors of 6. Okay, so factoring is just breaking it down. Instead of having something plus something plus something, it's just multiplied. Okay. Now, with the greatest common factor, we're just going to do the reverse of what we've been doing already. So if you remember the distributive property, okay, let's say, for example, if you have 5x times x plus 2. All you have to do is get this and distribute it to each of those terms. Let me raise that up a little bit. Okay, so 5x times x will give you 5x squared. And 5x times 2, 2 times 5 is 10, so that would give you 10x. Okay. Now, the greatest common factor just does this in reverse. Bless you. All right, so let's say if you want to use some steps for finding the greatest common factor. Let me move that up a little bit. Okay. From here on out, when you see GCF, that'll just be greatest common factor. Instead of writing greatest common factor over and over. Okay, so your first step is to write each term as a collection of factors. Now, these are just suggested steps. If you have another way that you factor and it works for you, feel free to do that. But this is one of those things where if you just wanted to break down each term and factor it out, you can. Okay. So for 2, you want to identify common factors. Okay, what does each term have in common? Okay. And 3, move the common factors to the front and all remaining factors are placed in parentheses. Oops, slide that up a little bit. No. Let's get writing. Okay. Okay, so let's say, for example, if you want to find the greatest common factor for, let's say, 6x squared, 10x to the third, and negative 8x. Okay, so remember your first step is to just break down each term. 6x squared, 10x to the third, negative 8x. You can actually make 6x squared 6, you can make that 2 times 3. And x squared, you can just make that x times x. Okay, so it's just 2 times 3 times x times x. 10x to the third, you can make that 10 2 times 5. And x to the third is just x times x times x. And negative 8x, you can make that negative 1 times 8 times x. Okay, so your second step is you want to identify the common factors. Okay, so for this one, 2 times 3 times x is your 6x squared. 2 times 5 times x times x times x is your 10x to the third. And negative 1 times 8 times x is your negative 8x. Okay, so out of all of these, they have, well, actually, I don't know why I didn't break down the 8, so if you look across that out, and this actually can be 2 times 2 times 2 times 2 times x. Sorry about that. Okay, so you have negative 1 times 2 times 2 times 2 times 2 times x equals negative 8x. Now you didn't have to make it negative 2 times 2 times, you could have made it 2 times 4 if you wanted to. Nope, sorry, one too many 2's. Okay, so you could have just made it 4 times 2 if you like, and that would have been fine too. Okay, so if you notice, each one has a 2 in common. And also each one has an x in common. Okay, so all the ones in common, you're just going to pull out to the front. Well, this is, they were added together. So you have a 2, and you have an x. Okay, why is that skipping? There we go. Okay, so that means your greatest common factor is just 2x. because that's really all they have in common. Okay, so if you want, you can underline them, you can circle them. It's completely up to you. But at some point, you just want to identify which ones they have in common. Okay. So any questions on that one? Okay. Now we're going to do the exact same thing, but we're just going to do it lined up, separated by plus and minuses. But it's the exact same step. Okay, so let's say, for example, we wanted to find the greatest common factor. Let me pick a good one. Let's say for problem A, 5AB plus 10A. And for problem B, y to the 5th minus y to the 12th. Okay. And there actually is a shortcut when you're dealing with factoring out variables. And I'll tell you that one when we get to problem B. Uh-oh. Okay. So if you have 5AB plus 10A, for your first step, this is already factored down as far as it's going to factor, so you can just leave it as 5 times A times B. Plus 10, you can make that 2 times 5 times A. Okay, so now you just want to identify what each term has in common. Okay, so you know that both of these terms have a 5 in common, and it has an A in common. Like I said, you can underline it, circle it, put a check over it, whichever way, but you just want to be able to identify it. Okay. Now, since you have a 5 and an A, oh, you already did the second step. Okay. Now, your third step, you're going to pull those out to the front. So since you have a 5 and an A here, you're going to have a 5 and an A there. Now, once you pull them out to the front, you're just going to cross them out. Okay? And remember, everything else lands inside the parentheses. So if you have a B here, after getting rid of the 5 and an A, then that B goes there. If you have a 2 here, after getting rid of the 5 and A, you have a 2 there. Okay. You can always double check it by, if you distribute that, you should end up right where you started. So 5A times B is 5AB. 5A times 2 is 10A. So it kind of takes you right back where you started. All right. So any questions on that one? Okay. So like I said, you don't have to do this method. It's just, I find that when you place steps on it, it's a little bit easier to follow. Okay, now for question B, move that up a little bit. Y to the 5th minus y to the 12th. You just want to find the greatest common factor. Okay, so your first step, you just want to rewrite it. So you have to kind of go back to the rules of exponents. So just a little side note, that if you have a to the m times n, a to the m times a to the, sorry about that, a to the n is equal to a to the m plus n. So really, when you're multiplying two bases with the same base and different exponents, you just add your exponents together. Okay, so that means This one you can actually leave as y to the 5th. And y to the 12th is equal to y to the 5th times y to the 7th. Because y to the 5th times y to the 7th is just y to the 5 plus 7, which is 12. Okay, so we have y to the 5th times y to the 7th. Okay. So now what you're going to do is you're going to get each one, you're going to identify what they have in common. So for your second step, just going to identify them, which of course is y to the 5th for both of them. And then for your third step, you're just going to pull that right out to the front. And when there's nothing left, what goes there is a 1. Because remember, if you distribute that y to the 5th times 1, it just becomes y to the 5th again. And this one is left as y to the 7th. Okay, so this is your greatest common factor. Oh, forgot to circle that one. Yeah, just factor out. So actually y to the 5th is your greatest common factor here. And 5a is your greatest common factor here. Okay. So any questions on that one? All right, let's do another example. Okay, so find the greatest common factor of, let's say, -9a to the 5th plus 18a squared minus 3a. Okay, so if we have -9a to the 5th plus 18a squared minus 3a, if we wanted to factor down each one of those, separate those into factors, 9a to the 5th or -9a to the 5th, the one thing you want to look at to kind of give you an idea of how far you want to factor is to just see that there's a 3 there. So which means you can break this down to 3 6 times 3. You can break this down to 3 times 3. So you can always kind of pick. You don't have to break this down to 3 times 3 times 2. You can just 6 times 3 and you're good. Okay, so you have -1 times 3 times 3. And the one thing you want to look at for exponents is you don't have to break them all down. Just look for the smallest, not exponents, for your variables. Look for the smallest exponent for your variable. If you have a to the 5th, a squared, and a, then all you have to do is look for that a to the 1st power. Whatever the smallest is, that's the one you're going to factor out. So that a to the 5th is just a times a to the 4th. Because all you need is an a, something you can pull out. Okay, so that would be plus 18a squared. Remember, all you need is a 3, something you can pull out of there, so you just make that 3 times 6 times a times a. And -3a, you make that minus 3 times a. Or you can make it plus -1 times 3 times a if you wanted to. Okay. Now your second step is just going to identify what they have in common. Okay. So you know that they have a 3 in common. And they have an a in common. Okay, which brings us to our third step. You're going to get what they have in common, bring it out to the front, and everything that left is going into the parentheses. So you have -1 times 3, which is -3, times a to the 4th. You have plus 6 times a. And when everything cancels out, it just becomes a 1. Okay, so that means the greatest common factor is 3a. Okay, so any questions on that one? All right. Yes.
So the solution would just be 3a is the greatest common factor. Do you have to have third step with it with the solution as well?
It depends on what they ask for. If they ask for just the greatest common factor, then you would just put 3a. But if they ask you to factor it, then you'd have to put the whole thing. So that's why I wanted to do the whole thing, because even though they may just ask for the greatest common factor, but if they just want you to factor it in general, then you'd have to do it that way. Okay, actually, that's a good question. Let me write down a little note. Asking for the greatest common factor, your answer will be 3a. If they ask you to factor the polynomial, then your answer is -9a, oh, I'm sorry about that, 3a times -3a to the 4th plus 6a, oh, sorry about that, minus 1. Okay. Because finding the greatest common factor is just saying we want you to pull out what they all have in common. But when they say factor the polynomial, they want you to rewrite that as just something times something. So in this case, it will be 3a times all of that. Okay. Any other questions? All right. Okay. Now the next thing we're going to go over is called factor by grouping. Anyone remembers factor by grouping? Okay. Okay. Now you use factor by grouping whenever you want to factor 4 terms. Okay. Now your steps, and we'll do a few examples of each, so because they're pretty tricky the way they sound, but we'll go through each step. Okay, so the first thing you want to do combine the terms in two groups so that each group has a common factor. Okay. Then you want to find the greatest common factor from each group. Okay. Now, if the greatest common factor is a binomial, and I'll just give you an example of that one. You know, factor it out. Okay. Now, in very rare cases, sometimes you just have to rearrange the terms and you'll be able to factor it. Okay. Now, if you rearrange the terms and you still don't have a way to factor it, then it's called a prime polynomial. That means it can't be factored. Okay. Kind of like how the number 5 can't be factored down to anything except 1 and 5. Same with 11 and 13 and 23. Those are just prime numbers. Same thing with prime polynomials. If you can't factor it down to anything else, it's called prime. So, okay. Make sure everyone has time to write that. All right. Okay, so let's say, for example, if you wanted to factor by grouping 15x to the third minus 10x squared plus 6x minus 4. Okay. Now remember, your first step, you're going to create two little subgroups. So you have 15x to the third minus 10x squared plus 6x minus 4. Okay, so what we're going to do is we're going to group these two together and these two together. Okay. Now your second step is you're going to find the greatest common factor of those two terms and the greatest common factor of those two terms.